Now that we're comfortable graphing our linear equations using either a table of values technique or going straight from y equals mx plus b using the slope and the y-intercept and putting them directly onto the graph, we're going to start to investigate the different types of graphs that we're going to encounter. And the two main types are what we call direct and partial variations. Okay? Direct and partial variation are important ideas, and more important in terms of how real-world situations reflect them. So if a variation is direct, it means that the y value varies directly with changes in the x value, and you have a bunch of different characteristics. So it's blue, okay. If it's direct, there's a point on the line that is 0, 0. And 0, 0 is a really special point. It even has its own name. We call it the origin. The origin is actually point 0, 0 on the graph. So a direct variation passes through the origin. A direct variation passes through the origin. It has a point on it that is 0, 0. And interestingly enough, if it goes through 0, 0, what do you think the b value is? We'll come back to that one in a second. A partial variation does not have a point 0, 0, ever. It does not pass through the origin. Does not pass through the origin. And remembering that the origin is that special point 0, 0 on our coordinate grid. Okay, so I know that the formatting is not quite right on the PDF that I'm working off of, so just translate it all into the format that you have on the notes that you were given. So there are 3 different ways of checking if your relation is direct or partial. And we're going to look at all of those. So the very first thing I'm going to do is I'm going to create a table of values and I'm going to graph so that I have all 3 representations of this linear relation. So let's create that table of values, x and y, x on the left, y on the right. I'm going to go -2, -1, 0, 1, 2, and then I'm going to fill that in. So let's say x is -2. So y equals -2, -2, y equals -4. X equals -1, y equals -1, -2, -3. -2, -1, and 0. Now let's translate those to the graph. So you can either take these points, put them on the graph, or you can use the y equals mx plus b technique. That's what I'm going to use because it's just a little bit quicker. So my b value is -2. My slope is 1 over 1. And we're going 1. It's positive, so the slope goes up this way, like that. I'm going to draw my relation. Oh, that's not a great line. Let's try that again. That's better. My arrows on the end. Okay. So now I have all 3 components that I need in order to determine whether it is partial or direct. So let's take a look. You guys can look back up at the top of your page and look at the definitions of partial and direct. So a direct variation must pass through 0, 0. Is there a 0, 0 on the table of values? No. Is there a 0, 0 on the graph? No. So we're going to look at 0, 0 there, and we're going to look at that point on the table of values. That's what we're interested in. So we have, it doesn't go through the origin. My apologies. Let me do some spelling. The origin. Okay. There's no 0, 0 point. So what is this? This is a, let's go therefore, this is a partial variation. So I've given you 2 clues. But what about the equation? There has to be a way to just look at the equation and figure out, is this partial or is this direct? Now, the clue that we need is in the table of values. If you look at the point that I highlighted in the table of values, you'll see that's the point where x equals 0. X equals 0 means it's on the y-axis. So what point is that? That's the y-intercept. So that's the y-intercept is 0b, remember? So b does not equal 0. That's the other clue. So I'm going to go back up to the top. I'm going to add this in here. B equals 0. Really, really important. That's the way you can check on your y equals mx plus b form of the equation like that right away to make sure that you understand if it's partial or direct. So if it's partial, b does not equal 0. So in this example we found all 3 ways. We looked at the equation, we said b does not equal 0. We looked at the table of values, we said there's no 0, 0 point. And we looked at the graph and said, hey, clearly it does not go through the origin, so it is not direct. Let's look at another example. Our equation is y equals negative x. That's strange. There's no b value. It's not negative x plus 3. It's not negative x minus 6. That's very weird. So let's take a look. Let's first create our table of values. Minus 2, minus 1, 0, 1, 2. As I said, I'm just picking those x values. You can pick whatever values you want. I would highly recommend picking one where x equals 0, since that's one of the points that we're really interested in this topic. So if x is negative 2, y equals negative x, negative negative 2 is positive 2. Positive 1, 0, negative 1, negative 2. Okay, let's put this on the graph. Negative x, we have 0, 0 right there. That's where it goes through, 0, 0. And it's negative x, so it's going to go this direction, like that. And let me draw my line using my handy dandy ruler. That's not a very good line, is it? Let me try that line again. There, that's better. Whoop. Sorry guys, moved that page. Arrows on the end. There we go. So, according to the graph, is this partial or direct? This is direct variation. It goes right through 0, 0, right through the origin. So because of the graph, I can tell. If I'm looking at the table of values, how can I tell? There's a point 0, 0 on the table of values. Okay, that's pretty easy. And then what am I looking for on the equation? Well, there's nothing beside x. B equals 0. That's negative x plus 0. But why would you ever write plus 0? It doesn't affect the answer at all. It doesn't change anything. So you don't write it. But what they're actually saying there is b equals 0. So we have b equals 0, 0.00, and it visibly going through the origin. And we've figured it out.